Hey everyone, in this video what we're going to do is we're going to solve the following integral taken from the 1939 Putnam Exam. So we have the integral from 1 to 3 of x minus 1 multiplied by 3 minus x all raised to minus 1/2. Let's begin by multiplying out what we have inside the minus 1/2. We have x minus 1 multiplied by 3 minus x, which is equal to 3x minus x squared minus 3 plus x. Now we can rearrange it in the following way so that we have minus x squared plus 4x minus 2 plus 1. And if we factor a minus 1 out of the first three terms, we have minus 1 multiplied by x squared minus 4x plus 2 plus 1. And we can rearrange that so that we have 1 minus x minus 2 all squared. This allows us to rewrite our integral as the integral from 1 to 3 of 1 divided by the square root of 1 minus x minus 2 all squared dx. Let's set u to be equal to x minus 2, and differentiating both sides we have du is equal to dx. The reason for doing so is it just makes the problem look a little bit cleaner. So we have the integral from minus 1 to 1 of 1 divided by the square root of 1 minus u squared du. Notice we've changed the limits of integration. We have to do that because we've made a substitution. Now let's set u to be equal to sine of z. Differentiating both sides we have du is equal to cosine of z dz. And of course, as before, we need to account for the fact that we've made a substitution. So let zb denote the upper limit of integration. We have inverse sine of 1 is equal to pi over 2, and let z sub a be equal to inverse sine of minus 1, which is equal to minus pi over 2. Now, we've made two substitutions here. We have u is equal to sine of z and u is equal to x minus 2. Is it possible to just do this via one substitution? Let me know in the comment section below. This allows us to rewrite our integral as the integral from minus pi over 2 to pi over 2 of 1 divided by the square root of 1 minus sine squared of z multiplied by cosine of z dz. And now we can make use of the Pythagorean identity. We can rearrange it so that we have cosine of x is equal to the square root of 1 minus sine squared of x. This means that our integral would become the integral from minus pi over 2 to pi over 2 of 1 over cosine of z multiplied by cosine of z dz, which of course just simplifies to the integral from minus pi over 2 to pi over 2 dz. And integrating this integral, we would have pi over 2 minus pi over 2, which is just equal to pi, which is the final answer to our problem. Make sure to like and subscribe if you found this content useful. Thank you very much for watching. If you have any questions or other problems you'd like to see get solved, leave them in the comment section below. I hope you have a great day.